This question states, list a sequence of transformations that maps the graph of y equals to e of x to the image with a graph with the equation y equals to this. So there are a few ways in which this can be done. So let's have a look at writing these two equations out. So this is your old equation. This is the old one. And your new one is y equals to 2e to the minus x minus 5. So what we're going to do, one of the ways in which we can compare and contrast these two is, first of all, we can just rewrite the new equation a little bit differently. So I'm going to get all the numbers that belong to y on the side of y. So what I mean by that, okay, this minus 5 is going to get transferred to the other side, so y plus 5, and then I'm going to divide it by this 2. All of these numbers here, the 2 and the minus 5, they actually belong and influence the y value, okay? Whereas the minus influences the x values. So this is the rearranged new equation, and the old equation is just like this. Now, what we're going to do is we will write the new equations with dashes on them. Okay? So we should have started from there. So what we're going to do is we're going to write the old y equation in terms of the new one. And then the old x value in terms of the new x value. So by doing this, we can see the changes that occur to the old y value to get it into the new y value. So to do this, so these are the equations. Now we have to express y dash and x dash. So we're just trying to find the brand new values. Okay, so what we have to do now is just multiply this by 2. So 2y equals to y dash plus 5, and then we've got minus x equals to x dash. So this one, we're just also going to rearrange it. So y dash is equal to, I'm going to bring the 5 over to the other side and just rearrange it. So 2 times y minus 5. And then x dash is equal to minus x. Okay, so to see this clearly, to state all the transformations, if we choose, say, to see it better, we can choose a value of 1 and 1. So this is an old value of x and an old value of y. What we can do is we can find now our new values of x and new value of y. And we would just have to plug x equals to 1 into this formula here, and we would get minus 1. And then we would have to plug y equal to 1 into this formula, and we would get an output of 2 times 1, so 2 minus 5. So we would get negative 3. So those are the changes that occurred to the coordinate 1, 1. It turned into negative 1 and negative 3 after the transformation has been applied. So looking at, the important transformations, the first one we discussed is dilation. Okay, so dilation is using a factor that multiplies either the x or y value or both by a certain number. So in this case, we can see that where the old y value, we're actually multiplying it by a factor of 2. And so if you think about what this means, if you have, let's take it back to the point 1 and then 1 for y. So if you have suddenly chosen to times the y value by a factor of 2, you're only going to be influencing the old y value. So the x position won't shift. It will just be the y value that will be multiplied by 2. And so the shift that has occurred is actually parallel to the y-axis. So there's a dilation by a factor of 2 parallel to the y-axis. You could also just as well say it's from the x-axis, because that would be the same kind of thing, except you're just looking at a different axis. So this is the dilation. Next, we can see that there's no x dilation. There's no number in front of x apart from -1, which actually correlates to the reflection. So the reflection, basically what has happened in the reflection is, if I get rid of this part, okay, and my axis has to be redrawn. If I choose a point here at 1 and 1, and now if I put a -1 in front of my x value, this part of my coordinate is going to be influenced. So it's still going to be present, but it's going to be on this side. So the values at -1 and 1. I'm not looking at the y dilation factor at this stage, at this moment. I'm just focusing only on the reflection. So this is a reflection in the y-axis. So because it's getting shifted from here, picked up and placed there, so it's around the y-axis. So the reflection is around the y-axis, because the x values have been influenced from positive to negative. Okay? So far we've listed 2 of the sequences of transformations. We also need to focus on the last one, which is translation. Now we can see that there's no x translation because there's no number adding or subtracting from x. Well, we can also see that the y has a translation. So the translation is 5 units down. So translated by 5 units down in along the y-axis. Okay. So these here would be your sequences of transformations that you would discuss. Okay, but it does require you to go through quite a bit of work in order to get there in the end. And it's very important the language that you use. So with dilations, you always talk about either parallel to a particular axis or from an axis. With reflections, you discuss around the axis, and with translations, you can say along the axis or in the positive or negative direction of x-axis, etc., depending on which direction you're going in. So that's one of the examples of a transformation question. Thank you.